The paper of the day is System R, Relational Approach to Database Management. System R is a database management system which provides a high-level relational data interface. The system provides a high level of data independence by isolating the end user as much as possible from underlying storage structures. The system permits definition of a variety of relational views on common underlying data. Data control features are provided, including authorization, integrity assertions, triggered transactions, a logging, and a recovery subsystem, and facilities for maintaining data consistency in a shared update environment. This paper contains a description of the overall architecture and design of the system. At the present time, the system is being implemented and the design evaluated. They emphasize that System R is a vehicle for research in database architecture and is not planned as a product. After reading this paper, it is clear that the traditional database architecture has not significantly changed since the System R project. System R provided the first implementation of SQL, the first demonstration of performant transactions, and provided the foundational groundwork in concurrency control and query optimization. The motivation behind System R was to prove that a relational database was possible, that it could provide adequate performance and query support for CORD's theoretical relational data model. System R's architecture is divided into two main components: the Relational Data System, RDS in short, and the Relational Storage System, RSS in short. Each of these systems has their own interface, the Relational Data Interface and the Relational Storage Interface, respectively. The Relational Data Interface is the external interface to the system, which can be called directly by the programming language using an early version of the SQL language as we know it today. After having received a query, the Relational Storage System performs any needed query optimization and chooses an appropriate access path to the underlying storage in the Relational Storage System. The portions of the paper most interesting are the ones that revolve around the storage system, the RSS. The RSS supports simple tuple at a time access to the relational data in the database while supporting data recovery and transaction management. Within the RSS, the data is stored in logical address space called segments, which are mapped to the physical address space to control clustering of data. All tuples of a given relation are stored within the same segment, and each segment consists of several equal-sized pages. These pages are allocated and freed as data is inserted and removed from the database. Pages are copied into a main memory buffer using queries to aid with concurrency control and transaction management. To handle segment recovery, a map between segments and pages is associated to two copies, current and backup. Any updates to a page made during a transaction are made to current, and those changes are saved to backup after all operations in a transaction are complete. System R also maintains a set of image relations. Images are a sorted view of the data, allowing for the ability to efficiently scan over relations according to some sort criteria. This allows the RSS to rapidly fetch a tuple by keying on the sorted field values. The images are implemented using B-trees. In addition to images, System R implements links, providing bidirectional access between parent and child relations. As new relations are defined in the database, new links are added to provide fast access between the equivalent of primary key, foreign key relationship. This function is important for supporting relational joins. Transaction management is handled through the maintenance of a time-ordered list of log entries which record information about each change to data. System R provides routines for replaying log entries or undoing log entries to handle aborted or failed transactions. All of these facilities or variations of them are replicated in one way or another in modern databases such as Postgres and MySQL. The contributions of System R are many: relational database management system, SQL support, transaction management, and recovery. The influence of the choices made by the System R team have been felt by database practitioners ever since.